You win?
Yeah.
Yeah, are you allowed to have that party?
Huh?
Are you allowed to have the party?
Yeah, I'm pretty sure.
I'm pretty sure.
Okay, do you have this one?
Okay, what's your goal?
I'm literally taking one house and giving these, I'm taping on the
It's Thursday of the weekend.
How's that?
Why don't you make this all real nice?
I do.
Right? See that?
Yeah.
We could make that scrinkle, you know, right? There's no reason why you
Okay,
can't
we want
go like this.
So today we're going to learn how to make that basic Dino Run game you just saw. It's about as simple as you can make it. Here's how it works. So first of all, I just used the circuit from the crystal ball project. So the wiring for the LCD is exactly the same. And first thing we do is we create the liquid crystal object, telling what the register select, enable, and D4 through D7 are connected to, like which pins on the Arduino. And then I've got an int holding the score that you're going to have, the position of the dyno, 1 if he's down on the ground, 0 if he's jumping in the air, because those are the indices, vertical row numbers for the LCD display. We've got an int holding the last button state just so we can see when it was just pressed, because that's an efficient way to do buttons. I've decided to have my player character be just this, my cactuses or whatever be just that, and it draws a little X if you've just died, where the player character was. I've got a little Boolean, true or false variable, that starts off false, and if you ever die, I just set this to true, and then it goes to a second screen where it just says, hey, your score was this. Nice work. And then I've got 2 times. Last time holds the last time the kind of like cactuses were updated. So every time it's been a certain amount of time since the last time you updated the cactuses, you update it again. And last button time, last time you press the button effectively, I use this twice. Once to check, hey, you've jumped up in the air. I use that to figure out when it's time for you to come back down. But I also use it so you can't just hold the button down and stay in the air the whole time. So I make you wait a very tiny amount of time in between coming back down and jumping again, just so you can't just hold the button down. And then I've got this guy. This is some of the secret sauce. This is a Boolean array holding 16 things called bottom because it holds the cactuses on the bottom of the screen. I could have called it cactuses. I don't know, whatever. My game only has like cactuses effectively, no pterodactyls for the Dino Run game. So you could easily add a Boolean top and just do the same kind of thing if you want to draw pterodactyls. By the way, if you did want to use fancier characters, you can make custom characters with the Arduino, so you could draw whatever you want and have that be a thing. You can look that up if you want. Anyway, my new bottom array just has everything defaulting to false, which I probably didn't have to do. I probably could have just done a semicolon after that. But to start off with, there's no cactuses on the screen. And a false means no cactus, true means there is a cactus. It's 16 because it's a 2x16 display, so there are 16 places a cactus could be. So in my setup, the thing that runs once when you start your code, I do lcd.begin. I say what size LCD I got. It's 16 across, 2 down. I also have a button, so the circuit for hooking up the LCD is exactly like the crystal ball project, but I did add a button connected to pin 6, and it just it's one side of it's connected to ground and the other side of it's connected to pin 6, and I can do that because I set it to input pull up. So by default it's high, and when you press the button it goes to low. And then I just set last time equal to the current time. Remember, millis just gives you the current time. in milliseconds since the Arduino is turned on or reset. And then we get into the loop. So the main game loop runs in this if statement. This if statement is huge. It's, well, the game is not over. Remember, this exclamation point means not. The game is not over. We save the current time because we use it in a few different places as an unsigned long. Remember, that's just a big fancy int, which can't be negative. I decided to call it now. That's equal to the number of milliseconds since we started the Arduino. Now this junk here is saying, hey, if it's been enough time that we want to shift the cactuses over again, because they shift over every so often. This is just kind of a fancy way to factor in your score. Like your score goes up every time things shift over, but I wanted it to speed up the higher your score was. So this is just saying, hey, if now is greater than the last time plus 700. So to start off with, when your score is 0, it's just 700 milliseconds in between stuff shifting over. But that will get less and less the bigger your score is. It takes your score and multiplies it by 1.5 and cuts off everything past the decimal point, because this whole casting to an int business. So yeah, it'll speed up. It'll happen more and more often that it'll shift the cactuses over as time passes, just because of this line. And then first thing I do is like this for loop. It'll happen 15 times. Once when C is 0, once when it's 1, once when it's 2, all the way up to 14. And it just basically says, hey, you know that cactus that used to be at position 1, now put it in position 0. So every location in the array just becomes equal to whatever it was before it. If there was a cactus to the right of it, now the cactus is at that position. If there was a gap to the right of it, now it's a gap. So it just shifts everything down in the array. But of course, we got to decide whether to create a cactus or not. In the final position, in the position 15, because remember you got positions 0 through 15. So we got a 1 in 6 chance. We roll a random die that has, actually I guess it's between 1 and 5. So I guess I have a between 1 and 5 chance, because this is the smallest number the random number can be, and this is 1 bigger than the biggest number it can be. So if it's equal to a 1, it generates a random number between 1 and 5. If it's a 1 and there's not both a cactus to the left of it and 2 to the left of it, then we put a new cactus in. It's fine if one of the things to the left of it or 2 to the left of it is a cactus, but if both are a cactus, you can't clear a three cactus jump, so it won't make that. This is just to make it so it doesn't randomly create impossible things to jump over. You might need to calibrate this better. I have not optimally tuned everything. So if this is true, you got your 1 in 5 chance, and it wouldn't make things impossible. We create the cactus. Otherwise, we make the last spot an empty space. And then we got to draw everything, because we updated kind of everything in our array, but we got to actually show that on the screen. So we clear the screen, and then we go to the position 0, 1, which is the bottom left position, and then just start drawing things in. I don't know, this should be 0. So starting at position 0, if bottom there, we print the wall character. So if there's a cactus there, we print the wall character or cactus character. Otherwise, if there's nothing there, because remember, this bottom array is either true or false. And so if it's true, we print the cactus because there's a cactus at that position. Otherwise, we print an empty space because there's nothing there. And then all this junk is for just drawing our dino, or the little like arrow thing. We set the cursor to 3 because he's in the 4th column, either up or down. Position being 0 if he's up and 1 if he's down. So we set our cursor to wherever we want to draw him. And we'll just draw him normally if he's up in the air because he's safe up in the air, or if there's no cactus at the bottom position where he's lined up. And if so, we're just going to print the player character wherever he's supposed to be, up or down. Otherwise, we're printing the dead character, an X, and we're setting game over to true because he's gone and hit a cactus. And then we set last time to now because we want to count out our 700 milliseconds minus whatever according to his score until the next time we shift everything over. So important line. And then we got everything else for the play thing is just focused on what to do with the button and should your dino come down, like has he been in the air long enough? So first thing we do, we read from our button, is it high or low? If it's currently low and last time it was high, with the way we've got the button wired, you must have just pressed the button. But you also have to be on the ground. So if you just press the button and you're on the ground and it hasn't been 300 milliseconds since the last time you landed, then you can jump. That's cool. You need to wait at least like 300 milliseconds, 0.3 seconds before you can jump again. You may want to alter that to give yourself more or less time. You got to stay on the ground between jumps. Then you set position to 0, which means you're up in the air. You're in row 0. You set last button time to now, so you can start counting how long you've been in the air for and if it's time to come down yet. You set the cursor to the bottom position where your dino used to be. Print a space where he used to be. And then draw him up in the air. Set the cursor to the up in the air position above where he was, and then print him. And then this junk is to see, like, hey, if he's up in the air and he's been in the air too long, like if he's been in the air 3 seconds or more, like if the current time minus the time he entered the air is greater than or equal to 3,000 milliseconds or 3 seconds, we want to save that we've landed, so we use that with this, so you can't just hold down the button and stay in the air all the time. We want to set position to 1, which means they're on the ground. We want to draw empty space up in the air where he used to be, and oh geez, what am I doing here? My bad. I don't think I had him coming on the ground at the proper time. So we should have set him on the ground. So set the cursor on the ground. If there's a cactus there, he's dead. And let's go print an X there and set game over to true. Otherwise, if there's no cactus there on the ground, then we just print the player character there. And then we save our last button state to button state. Delay 5 milliseconds, 5,000ths of a second. So just useful so we're not just constantly updating the LCD, not making it work too hard, giving it a little bit of time to reset everything. Yeah, and you wouldn't even notice 5,000ths of a second. So this ties to the if it's not a game over, if you get to the end of here and it is a game over, it'll wait 4 seconds so you can see, oh yeah, I did get hit by that cactus, so it'll show the screen for the 4 seconds, then clear the screen, print your score was, wait half a second, and then move to the bottom a little bit over so it's more in the middle, and then print your score, and then wait 10 seconds, but then it'll keep doing it again and again. So that's it. So hopefully this helped. Thanks for listening.